Hey guys, I'd like for you to do one thing to prove something to yourself before you dive into today's lesson. There's a concept that you need to have kind of firm in your head before you really get what a video that I'm going to show you is trying to tell you. And that is the difference between linear growth in a population and exponential growth in a population. And I want you to see it in two different populations of people who are getting sick. We'll look at heart disease, which is not infectious, but every day there's a certain number of people who are diagnosed with heart disease on average. And then there's viral infections. And that's a little bit different because if you've got one person who's infected the first day, then the next day, if they've infected somebody else, that new person can also infect another person the next day. So that's a little bit different because heart disease patients are not connected to each other, but viral infections are. So we're going to pretend in this little example that heart disease grows in a linear fashion and that viral infections grow exponentially, which is for the most part true. So if you look at patients that are diagnosed with heart disease, and let's start out the same way in both groups here. Let's start out with one person who is sick on day one, right? So if on day one person has heart disease, and let's say the next day, let's pretend that 2 people every day are diagnosed with heart disease on average. So we're going to add 2 to the population that are sick every day, plus 2. So day 1, there's 1 person. The next day, there are 2 more people who are sick. So there's day 2. Day 3, we would add 2 more people. And day 4, we would add 2 more people. So by day 4, we've got 7 people that are ill with heart disease. Now, with viral infections, you've got 1 person who's sick on the first day. That person, though, can infect another person on the second day. So you'll see on the second day, there's not quite as many as there were on the second day with heart disease, because there were 3 on the second day with that, only 2 here. So it looks like it's going to grow at a slower rate. But now on day 3, you've got to keep in mind that both of these people can infect new people, right? So that's a little bit of a different type of growth. What we're doing here is we're doubling things. This is 2 times, not 2 plus, but doubled 2 times the number on every day. So on day 2, you had 2, but on day 3, both of those can infect somebody. So you go from 2 to 4. 2 times 2 is 4, right? And then on day 4, you've got to remember that every one of those people can infect someone. So that one and that one and that one and that one can all get someone new sick, right? So if you count those up, by day 4, you've got 8 people who are sick with a viral infection. And that's different. The numbers are different. It's growing at a different rate. Now, it doesn't seem like much yet, but you have to wait to see what happens, right? Because it is a big difference eventually. And we're giving it the benefit of the doubt. We're just saying that first person on the first day could only infect 1 other person, and that it only doubles the next day. But keep in mind, with a real viral infection, that first person on the first day, if they sat around, 7 or 8 friends and all their friends got it, this could be 8 times or something. But we'll keep it simple and we'll just say we're adding 2 people every day for heart disease, plus 2, and we're doubling the number of people who are infected every day for the viral infections. Now, I'd like for you to make a graph out of this. Nothing too fancy. And if you don't have a ruler, that's fine. Find yourself a piece of paper and fold it up. Make yourself a ruler, straight edge, right? That's fine. I won't use any of my wife's fancy rulers here. I'll just use this. So when you're making a graph, math class will tell you there's X and Y axes on the graph. And those are just, the sides and the bottom of your graph. So I'm going to put a line there, and I'm going to darken in this line here. Between my X and my Y axis. Now, the bottom down here is almost always time when you're looking at a population growing or something like that. So down here at the bottom, we're going to say this is days. And I'm going to mark a few on here. I'm just using like every other line here on my paper ruler. Every line, I'm going to make a slash mark. Now, I know I'm not going to get many days on here, but that's okay. You'll see that you're going to run out of room really fast when this gets to going. So there's day 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that'll be plenty of days. Now, up the side here, I'm going to go up by 2 so I can cram more numbers here. Now, remember, you don't put a number in the corner here. That is 0 right there, right? So the first line up, 2 people, 4, I'm miscounting. Don't tell the math teacher. 2, 4, 6, 8, 10, 12, 14, 16, 18. And if you keep going up by 2s, I think up here at the top, you get up to like 52 or something at the top. You'll see when you make the rest of the graph there. But so I've gone up by 2s. And keep in mind, just because I'm going up by 2s doesn't mean that 1 and 3 and 5 do not exist on the graph. They do. They're just in between, right? Like 1 would be right there. It's in between the 0 and the 2, right? So I'm going to graph these 2 populations on this chart. And then I can look at the differences, right? So heart disease, remember that we're starting out with 1 person, and then we're going to add 2 every day. We're going to add 2 people every day. So we're starting out with 1 person. So here's how you figure that out. Day 1, 1 person, right? The side here, I should have put a label here. Number of, that's number of, not hashtag. Number of sick people. Number of sick people. Okay, so on day 1, I'm going to have 1 person with heart disease, right? And then on day 2, I'm going to add 2 to that. So 1 plus 2 is 3. So on day 2, I'm going to come up to where 3 would be, and I'll put a dot there. And on day 3, I'm going to add 2 to that. 3, let's see. We started out with 1, and then we added 2, so we got 3, and now I'm going to add 2 to that and get 5. So day 3, I'm going to come up to where 5 would be on the chart and put a dot there. Now, once you get all these on here, I'm not going the whole way here. You've got to figure out the rest of them. But once you get all those on there, you're going to draw a line between them, right, to show the growth in that population. Now, once you get all those on there for like 8 or 9 days, then you're going to come back and you're going to do the viral infection population. And we're going to start out with 1 person on day 1 again. But this time, we're going to double that every day. Every day, the number gets multiplied by 2, doubled. So on day 1, I'm going to have 1. I'm going to put it right beside that one because it's the same number as had heart disease on day 1. But then on day 2, 1 times 2 is 2. So the next dot for that one's going to be right here. And the next day, right, so I had 1 on the first day. 1 times 2 is 2 on the second day. And then take that number and double it again. So the next day is going to be 4, right? So on day 3, I'm going to have 4. So the next dot's going to go right there, right? And I'm going to connect these as well, right? You can see it growing. And it looks like that the viral infection group is not growing as fast as the heart disease group, right? But that's what I want you to see. I want you to see what happens as that population gets going, because there's going to be a big difference between linear growth and exponential growth as you continue these on up the chart. And you're going to run out, and that's okay. The numbers are going to shoot off the top of the paper, and that's what I want you to see for the lesson today, so that when they're talking about exponential growth in this video about viruses, you will know exactly what they're talking about because you can look back at your graph. All right. Now this is just to go along with the lesson today, something to look at while you answer those questions. You don't need to attach this to the lesson today. Okay. Hope that helps. See you later.